an example concerning collisions, elastic and inelastic collisions. And we say that when we say perfectly inelastic is when the bodies stick together. If they say inelastic, the bodies, they don't stick together. Though they don't, kinetic energy is not conserved. You understand? So here, in a perfect inelastic, kinetic energy is not conserved. However, the balls stick together. So perfect, it means total inelastic, okay? So or completely elastic. So we have balls P, Q, and R, masses M1, M2, and M3 lie on a smooth horizontal surface, and they are initially at rest. So the ball P is now given an initial velocity, moves towards Q, makes an elastic collision with it. Then Q moves with the makes perfect elastic collision with R. Show that. So if Q makes perfect elastic collision with R, it means that both Q and R will stick together. So now the sketch will be like this. How do we sketch this one? So let me say this is what? This is P. This is what? This is it? Q. Okay? This is what? This is R. Now they are saying that P and Q, they collide. So when they collide perfectly inelastic. So meaning that after collision, we shall have P again here. We shall have Q here again. Okay? Then we shall have R here again. R. Okay? Now after collision, Q and R, they move together. Q. This is the Q, this is R, with the velocity which is V, they are calling it V2. This is given the velocity U1, this is at rest, U2 is 0, U3 is equal to 0, okay? Now after collision, P, what happens to P? This now, we shall say this is a velocity of P, this is a velocity of Q, okay? Then after that, we shall be able to eliminate Vp and V2, because since the equation does not have these two, we shall be able to eliminate. So we start with the P and Q, okay? Start with the PQ first. P and Q. That's the elastic collision, so conserve momentum. Conservation of momentum. Conservation of of momentum. So we shall have M1, U1. Now this one has no momentum because it was initially at rest. So this will be M1, okay, Vp plus M2 Vq. Now since it is Q colliding with the R, then we don't need, we first eliminate the velocity of what? This velocity. So that divided is by what? By M1, that is U1 is equal to Vp plus M2 over M1 Vq. So we make this as the subject, so the Vp will not become U1 minus M2 over M1 Vq. Equation 1. Then conservation of energy. Of kinetic energy. So kinetic energy is also conserved, you know that, right? So we shall now say I have M1 U1 squared is equal to I have M1 Vp squared plus I have M2 Vq squared. So we divide both sides by what? So Vp squared will become U1 squared minus M2 over M1 V squared equation 2. Put 1 into 2. Okay? So we shall have U1 minus M2 over M1. This is V2 squared should give us U1 squared minus M2 over M1. This one V2 squared. Open brackets, we shall have U1 squared, okay, minus, So when I open bracket, A minus B squared is the same as A squared plus B squared minus 2AB plus B squared plus this one, that is M2 over M1 squared V2 what squared. Okay? Minus 2AB. Minus 2AB minus 2 M1, so M2 over M1 U1 V what V2. Now this one will give us U1 squared minus M2 over M1 V2 what V2 squared. So U1 will cancel with this. What else is cancelling? Okay, nothing. Let us use this part here. So the rest we shall have now, we are left with, divide both sides by M2 over M1. Okay? Okay, we have M2 over M1, that is squared V2 squared, okay? Minus 2 M2 over M1 V2 U1, giving us a negative of M2 over M1 V2 squared. So dividing through by what? Through by M2 over M1 V2. Okay? So divide through this one, we shall end with only M2 over M1, then V2. You get it? Minus, here when you divide, you are left with U1, 2U1 only, 2U1. The other side will be a negative of what? M2 of M1 will go, V1, V2 will go. So we are left with V2. Now, this one is same as M2, okay? V2, multiply both sides by M1 minus 2 M1 U1 is equal to M negative M1 V2. Correct like terms? So what V2 one side? So M2, okay? M2 V2 plus M1 V2. This one goes that side, becomes 2 M1 U1. So meaning that our V2 will become 2 M1 U1 divided by, here you factorize, that's the M1 plus M2. Equation what? Let us call this one equation 3. Then we go to condition between what? 4, 2 and R. 2 and R. This is a perfect inelastic. Perfect what? Inelastic. Conserve what? Momentum only. So we conserve momentum, there is no kinetic energy. So we shall say, for this will be, this one is already in motion, this one is at rest. So that is M2, that times V what? V2, okay? Is equal to M2 plus M3. They move together with the common velocity which we are putting in V what? V2. So, meaning we are looking for V2. Our V2 will not become, is this one okay? Our V2 will become M2 V2 over M2 plus M what? M3. So, this is equation 4. Put 3 in 4. Put 3 in what? In 4. Put 3 in what? Put 3 in 4. Put 3 in 4. So we shall have V2 as divided as V2, we substitute this. That is 2M1 M2. 2M1 M2 U1 divided by M1 plus M2 into M2 plus M3. So that is it, how we can simply show that, okay? So we have number 2, a truck of mass 1 ton traveling at 4 meters per second collides with another truck of mass 2 tons. So if the collision is what? Is perfect inelastic, find the common velocity after collision. So what will be the common velocity after collision? So here you can sketch the diagram, or you may just can sketch, but even if I don't sketch, I just know since the collision is perfect inelastic, it means that m1 u1 plus m2 u2 is equal to m1 plus m2 times what? Times v. But now, if these bodies were moving in the opposite direction, then one of them will have a negative momentum, since momentum is a vector quantity. You understand? If they are moving in the opposite direction, supposing the second track was moving, well, this is due west and this is due east. So this one will due east, opposite direction, we will put a negative here, okay? We will put a negative on the momentum, since momentum itself is a vector quantity. You understand? So we shall now say this is 1 turn. That's the 1 turn, so that's 1,000 times z times the track. The first track was moving at 4 plus 2 turns, 2,000. It was moving at 3, I think, giving us, when you add, you get 3,000 turns, 3,000 kilograms times v. So this is 4,000 plus this is 6,000, giving us 3. So our v will become, this is 10,000 divided by 3,000. So which becomes 10 over what? Over 3, that's 3.33 meters per second. Now they're saying that find the loss in kinetic energy. So the kinetic energy got lost, okay? So we shall say back to kinetic energy lost is equal to initial kinetic energy minus final kinetic energy. So which means that this will now become a half m1 u1 squared plus kinetic energy of the second body, which is a half m2 u2 squared, then minus a half m1 plus m2 v squared. So we substitute, a half can go out, so this is a half. M1, that's 1,000 times 4 squared, plus this is 2,000 times 3 squared, minus this is this plus that, you get 3,000 times 3.33 squared. So when you substitute, you get your answer in joules. You get your answer in what? In joules. And what will be the answer? Our answer will become 333 point, how many? That's 333.3 joules like that. So I think I can put now what? The exercise. So now if they say account for the kinetic energy loss, what do you say? You say that the kinetic energy is lost in form of heat and what? Sound. So during the collision, there is heat that is produced due to the molecular vibrations at that point of collision. So heat is dissipated. So that is kinetic energy converted to heat, and at the same time, sound is produced. There is no collision that you've seen without what? Sound. Now, whenever you hear sound, that tells you that it is inelastic collision. When there is no sound, like gas molecules, there you don't hear sound. Okay, that one you say it is what? It is elastic collision. Is that okay? So let us look at the exercise now. Okay. So this is the exercise. Number 1. They are talking about two particles of masses 0.2 and 0.4 are approaching each other with velocities 4 and 3. On collision, the first particle reverses direction and moves with the velocity of 2.5. Find the velocity of the second particle after collision. So here, and percentage loss in kinetic energy. So this is inelastic collision. This is inelastic. It is not perfect, but it is inelastic because bodies separate and move with the separate velocities. Okay, but the kinetic energy is not conserved. Okay, there's also kinetic energy, so you have to get kinetic energy before collision and after collision. Now, when I get kinetic energy, kinetic energy is a scalar. So, as we say that a half mv squared, we shall use a half mu squared. We shall use positive values because on momentum we shall use, if one particle was in the opposite direction, we shall use a negative on that velocity. Or maybe this one is the one which was approaching in the reverse direction. So this one you put a negative, or you put a momentum which is a negative here. So the momentum of this second part could be negative as perpetuating the first part. Okay? Because you have to sketch and see which one is in the reverse what direction. Then this one, you are getting kinetic energy. Kinetic energy is a scalar, so we don't use what? We don't use the negative sign. The negative here is a sign that the momentum is what? Is a vector, and therefore it's a sign that one particle is moving in the opposite direction. But kinetic energy has no directions. Okay? So when I substitute for kinetic energy, please don't include what? The negative sign. Then a body of mass, so this one is also okay. Then this is the balls A and B of masses M1 and M2, initially approaching each other with the velocities U1 and U2 respectively, had a head-on collision. If A continued in its original direction with the velocity V1 and B reversed direction with the velocity V2. So after collision, it implies that they moved in the same direction. But before that, they were in opposite direction. So when you're conserving momentum, you know where to put a negative, and when you're conserving kinetic energy, there is no negative. Is that okay? Yeah. So let us proceed. So we proceed. We go to ballistic pendulum, and is a device. Use it to determine the speed of the blade. Determine the speed of the water of the blade. So let us consider, let me say, this is the suspension, and here we are going to consider, here initially there was, let's consider this one as a block of wood of mass M. Block of wood of mass capital M. This is a block of wood of mass what? Capital M. Then you consider a bullet fired from a short distance. So this is the mass of the bullet. So this is the mass of the wood. Let us put MW. Initially moving with the velocity U of the bullet. Okay. Now after collision, the bullet gets embedded in the wood and they come here. After collision, the bullet will be in the wood, will get stuck in the wood, and it will be there, such that here we shall have initially the wood was here, so the height is we call it H, okay? The length we call it L, from here to here, okay? So the angle of swing is theta, and here, of course, they are moving with the common velocity, which is what? Which is it? The common velocity is what? Is it? Is V. So this one is initial at what? At rest. So then we shall now say that if this is theta, remember this is also what? So we have said from here to here is H, not so? This is H. Now, if that is H, let's say, if I have cos of theta, adjacent, which is this one here, so this will be, this is, remember from here to here is L, so this is L minus what? Minus H, like that. L minus what? H. Okay? L minus H. So that means, so from there, okay, we shall now say, from here, we can also, using the conservation of linear momentum, using conservation of linear momentum. We shall come here, mass of the bullet, speed of the bullet is equal to mass of the bullet plus mass of the wood times the common velocity. So what will be the speed of the breath? We make the subject. Speed of the breath will become mass of the breath plus mass of the wood divided by mass of the breath times the common velocity, which is V. Call it equation what? Equation 1. Because we are looking for the speed of the breath. Now, kinetic energy. Now here, kinetic energy here is equal to 0. Okay? Then the potential energy will become mgh. M plus mass of the wood times g what? H. So meaning that at that point, kinetic energy of composite mass after collision. So kinetic energy. Let me say this is at A, this is at B. At B is equal to potential energy at B. So there is conservation of energy because kinetic energy is converted to potential energy. So the kinetic energy after collision is a half mass of the breath plus mass of the wood. Okay? At B, times V squared will become mass of the breath plus mass of the wood, GH. Okay? So this will cancel. We shall say that our V will become, our V squared will become 2G what? 2GH. That is our what? Our V. So our V becomes square root of 2G what? 2GH. Equal to equation what? 2. Why don't we are going to substitute 2 in what? In 1. Put 2 in 1. Put what? Put 2 in 1. So we shall now say that U of the breath, okay, here, 1 is here, is equal to mass of the breath plus mass of the wood divided by mass of the breath times V. But our V we've gotten square root of 2GH. Okay? So now we go on. That's how to get the mass of the heart, the mass of the wood. So the speed of the heart of the breath. Now as we move on, you might know that H must be that H is what is measured. Okay? So let me say that's what we have. But now let us look for H. What is that H? From here, cos of theta, but cos of theta will become here, it is adjacent, that is L minus H over hypotenuse, which is L. So L minus H is equal to L cos theta. So now H will become L minus L cos what? Theta, not so? So H will become L into 1 minus cos of theta. Therefore, our speed of the breath will now become mass of the breath plus mass of the wood divided by mass of the breath. Okay, then we square root of 2G into 2GL into 1 minus cos of theta. And square root. And square what? Root. So I think now the rest you can measure. The length of the string is measured, the angle of the string is measured, the masses are measured, the speed of the breath can be gotten from that. Then we go and look at factors on which the angle of string depends. Factors on which angle of string theta depends. What are those factors? Factors on which the arm of spring depends. Speed of the breath and length of the what is the speed of the what? And length of the string. Of the string. As you can see here, speed of the breath and length of the string. The rest are constants. The rest are what? Are constants. Okay? The angle of the spring can be obtained. The angle of the spring can be obtained. Then let us go and look at examples. Okay? Examples. So we are here. A bullet of mass 50 grams is fired horizontally into a block of wood of mass 8 kilograms, which is suspended by a string of length 2.5 meters. After the collision, the block swings upwards at an angle of 30 degrees to the vertical, of course, to the vertical. Calculate the speed of the bullet if the collision was perfectly inelastic. So we can first sketch. We have a sketch, I will sketch it. Is this enough? Okay, we can sketch it here. Let's sketch it here so that we can have enough space. So this is a block of wood. So that's the mass of the wood. The bullet is here fired from a short range. The bullet, mass of the bullet, speed of the bullet. Then after collision, this one swings through an angle 30. The bullet gets inside. Okay. So and this is height h. We say this is length L, and this will be L minus h. This is the theta. Because this is h from here to here. This is h. So they're saying. So we shall now say conserve the momentum first. So mass of the bullet, speed of the bullet is equal to mass of the bullet plus mass of the wood. Then times what? Times v. So this is 50 over 1000 times speed of the bullet is equal to, this is 50 over 1000 is 0.05 plus 8 times v. So speed of the UB will become 8.05 divided by 0.055 times speed of the what? The common velocity. So what do you get there? What calculator? So we have 8.05 divided by 0.05. Our answer is 161. So it gives us 161. Equation 1. Okay? But potential energy, so kinetic energy is converted to what? Potential energy at here. Okay? So we shall now say that I have mass of the bullet plus mass of the wood. Then that v squared is equal to mgh, mass of the bullet plus mass of the wood times g what? H. So this will cancel with that. So meaning that our v squared will not become, our v becomes square root of 2gh. But our h, we said cos of theta is equal to L minus h over L. So our h will now become L into 1 minus cos of theta. So substitute. So our h becomes L. Our length is 2 meters. Is it meters? 2.5. 2.5 into 1 minus cos of 30. What did you get? 1 minus cos of 30 equals then times 2.5. The answer is 0.3. Our h will become 0.3349 meters. So we substitute. Therefore, our v become square root of 2 gh times 9.81 times 0.3349 and square root. What we get? 0.3349 times 2 times 9.81 equals under square root of the answer. We have our v will become 2.563 meters per second. Therefore, our rest of the bullet will now become 161 times this one, which is 2.563. So the answer becomes 161 times 2.563. So it becomes 412.643 meters per second. I think that's what the question is asking us to get. Find what? Calculate the speed of the bullet if the collision was perfectly inelastic. So that's the number one. We go to number what? Number two. We go to number what? Number. So this is the exercise. A bullet of mass. So this is a bullet. They have given us mass. The speed is given. So they are asking us the vertical height through which the block rises and maximum angle of inclination. So the steps of doing this work here. Number one, conserve momentum. That's number one. Number two, conserve mechanical energy. Mechanical energy. Potential energy is kinetic energy is converted to potential energy. So those are the two steps that can lead you to the solutions of these ones. Okay. So then the other three is look at the height. The height, like how I brought in cos, cos theta. So they can always ask you to get that angle theta. So if you know the height, you know the length, you can get the what? The angle of a swing. Now like this one here, the hint is, for example, if you have this, this is B. Now this one is rises here, like this, through angle what? Theta. Now this one is going to start what? Is going to collide with B. This is A, it's going to collide with B. So after colliding with B, they will come like this. This will come, they will be in contact. They will be in contact, this is B, like that. So they want this angle through. Now this angle is alpha. That angle is what? Is alpha. Because I said, find the height through which I'm here. If that angle, because this angle cannot be the same angle as this one, understand? So it means that here, first of all, conserve. You know, here this one comes with the speed U, okay? Strikes, isn't it? But then remember here, you have, remember it was here. So you have the H1, here you have H1, you have H2, which is not the same as this one. You have H2 here, this is H1, H2. So that means that if we are saying that find the height through which B rises, it is H1, H2. So here they're looking for this speed here. How do we get speed? Conserve. Here it is potential energy is equal to kinetic energy. So you'll be able to get your value from here. Then after that, now as you are moving, remember there is you get value, okay? But as you're colliding with this one, as is colliding with this one, remember if you have the length error, for example, okay? And maybe you say that U is equal to square root of what? 2G what? H1. Okay? But you don't have H1. But you know that our H1 is equal to error into 1 minus cos of what? Cos of theta. That's H1. Then H2 here will be equal to H2 will be equal to error into 1 minus cos of what? Alpha. So do you have these angles? The issue is, do you have those angles? So you have to first get the angle. So now in this case, of course, when they tell you to do that, they are telling you find. So that height, the answer you'll be able to get the answer here. The height H2 will be equal to 9G L into 1 minus cos of theta divided by 16. That will be the answer that we'll be able to get. Is that okay? Yes. Let us go to an experiment to determine the speed of the bullet. Okay? The speed of the bullet. So this is the experiment to determine the speed of bullet using ballistic pendulum. So one, we already know our equation. We already know this equation. Okay? So we need to get the length of the string and the angle of the string. So how do we measure the angles of string? Use a protractor. So we must have a protractor, and we must have a meter rule which is going to measure the length of the string. This is mass. These are masses. So we shall say known masses. Okay. So we shall start by saying that a massive wooden block. It is massive because if it is not heavy, once the bullet strikes it, it will just go and it will even. The string will even break. So it must be heavy that it is able, the bullet is not going to overpower it and it moves far, okay? So it should be a massive wooden block of non-mass that is suspended from a fixed point by string freshly blackened with charcoal. Why do we blacken it with charcoal? So that when it moves along the protractor, it will darken that part on the protractor, and the angle which is covered by the darkened part. That means that will be the angle through which the string moved. So a protractor is now fixed at the point of suspension. Okay, as shown below. So that to measure the angle of swing. Then we say that a bullet of known mass m, small m, is fired from across range towards the wood. From across the range towards the wood, so that it gets embedded into the wood. Then the first angle of swing, theta, is measured and recorded using a protractor. The length of the string is measured and recorded using a meter rule, and then the speed of the bullet will be gotten from this expression which we have already seen. Is that okay? So we can have one other number exercise, and put here also another number, another exercise. Okay? So such a question is they give 5 marks. They give how many marks? 5. So we have this one, 2 pendulum of equal length, 1.2 half bulbs A and B of masses 2m and 3m respectively. The pendulum are hung with bulbs in contact. Now, so we have this, so that is the question. So we can now go ahead and look at, we go ahead. So anyway, these are the questions. I think we've known how to treat them, not so? We've known them how to treat them. So we're going to look at another thing, which is, so we are looking at collision in 2 dimensions. So we have a body of mass M1 moving towards the body B of mass M1. This mass is M2, of mass M2. Now, after collision, they move with separate velocities in different directions. Let this one make an angle alpha to theta, and make this one make an angle alpha to the horizontal. Now, this one, this velocity, since it is a vector quantity, it has both horizontal component and vertical component. So what will be the horizontal component of this one? So the horizontal component will be V1 cos of alpha. This will be V2, this one here, V2 cos of theta, like that. Then vertical component shall have the vertical components. Okay. Now the vertical component of this will be sine, that is V what? V2 sine of theta. Now this one, now in this quadrant, sine is negative, so it will become negative V, V1 sine of alpha. Negative V1 sine of alpha. So we shall now say horizontal motion. Shall now say horizontal motion. Motion along x-axis. This is y axis. This is x-axis. Motion along x-axis. We have momentum before collision is m1, u1 is equal to momentum after collision. It will be along horizontal axis. It will be m1 times the speed. The speed is what? Is v1 plus what? V1 cos of alpha plus this one. That's the m2. V2 cos of theta. That's what. Then we go to along with the vertical along with the vertical motion along y-axis. Motion along y-axis. Now along y-axis, since this one was moving horizontally, then it did not have under vertical motion. The initial momentum was 0 because none of the bodies were moving under vertical motion. So this is 0 will be equal to for A this is negative m1 v1 cos of alpha plus for B is m2 v2 sine of alpha, sine of theta. Sorry, this is sine of alpha. Sine of alpha. So that means that m1 v1 sine of alpha is equal to m2 v2 sine of theta. Now, if they say that show that whether the collision was elastic or inelastic, you have to get kinetic energy before collision and kinetic energy after collision. However, when you're getting kinetic energy, we don't use angles, okay? Because kinetic energy is a scalar quantity. So we use the speed, this v2 and v1, but not using v1 cos alpha, no. We use v2, v1 to get the kinetic energy. You understand? So we are going to have to look at examples. We're going to look at the examples that involve the collisions in 2 dimensions. Is that okay?